Hey guys, we're actually getting the very last lesson for this semester. It's how to prove parallelograms. So basically I'm going to look at quadrilaterals now. I'm going to decide if they're going to be a parallelogram. Now there is one way that you can always use, and that's the definition. Remember, you can show two pairs of opposite sides parallel, and that would make a parallelogram. So don't ever forget the definition is one method. But we're actually going to get a couple other methods that I just think are really easy to do. And don't forget the fact that I think that you guys are very capable, but remember converses. If I start with a property, that means I probably can flip it around and use that to my advantage. Now this first one is a new one. It's a combo pack, and it will work out really well. It's using proving congruent triangles. But with this first one, let's write it down. If one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. So now I want to prove one exact pair. You don't have to worry about another pair. You just look for one pair of opposite sides. Makes it really easy. So that's our first condition. Now we have another one, and this one's kind of common sense because this is strictly the converse of what we had before. On the next one, it says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. And the way we could show that is we would actually use congruent triangles again. I would use side, side, side to show the triangles are congruent, and then I would have my corresponding parts of congruent triangles showing me these parallel, these congruent angles, which makes parallel sides because they're alternate interior angles, and it would prove that it's a parallelogram. So on this one, we just need to show opposite pairs of sides are congruent, and we can assume all this other information about parallelograms. Now the next one's also a converse. I'm just going to put converses here. So we have those. On 6.3, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So now we're looking for pairs. Kind of a cool thing here. So it's pretty easy. Now, we also some other ones that can work. They're actually using our other converses too. So let's think flip-flops. We know the properties where opposite pairs of parallel sides are congruent, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, and consecutive angles are supplementary. I still have to use two of those. Consecutive angles are supplementary, and the diagonals bisect each other. So here's the one using the consecutive angles. It's the following. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. Now I used abbreviations here, but the reason why they're doing this is if they're supplementary, I know those two sides would be parallel, and I could prove these two sides being parallel by same side interior angles. And then last but not least, we have our diagonals. And the cool thing about these is we could use congruent triangles again to our advantage to prove this. But here's all we have to remember. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So it works out pretty easy again, but again, I'm looking for these properties. Again, aren't those converses of what we had before? Yeah, it's just the converses of what we learned the other day. So not real difficult when you have those.